Hello, in this video, I will explain to you on how to find the P here, the voltage here in this circuit. So our goal is to find out what is P. And then we are asked to use the node voltage method, or some other books called it nodal analysis. Node voltage method. And the first step that we need to do is to label all the nodes. Label all the nodes. And also extracting some necessary information, right? Okay, let's set this bottommost node here as our reference node. Our reference node or our ground. And that means that the voltage in this ground is equal to 0. But then right off the bat, we know that this one here, this node, is 30 volt from the ground. So we'll have 30 volt here. Good. And we have two essential nodes. Let's name this node as node A. So I will have PA here. But then I also have PB here. Because I named this node as node B. But then the voltage here will be VB. Good. But then I have one non-essential nodes that I want to label. Why? Because we need to find out V, right? And let's name this node as node C. So we'll have VC here. Why that is important? Because if we have our positive terminal here and our negative terminal here, we can get our V, right? What is V? P is where is the positive terminal, VC, minus where is the negative terminal, the reference node. So I'll have 0. So we will have P is equal to VC. So if we can find VC, we have P here, right? So that's why I label these non-essential nodes. Okay, now let's do the second step, which is assume the current direction. Assume the current's direction. Okay, and for the branch with the current source, I just follow the arrow. It will goes up and eventually goes to the right. For the vertical branch, I usually goes down. So I have this one and this one. And then for the horizontal one, I usually goes to the right. So I have this one and that one and also this one here. Good. Now what can we do? We need to do KCL for all unknown nodes. Do KCL for all unknown nodes. Okay, we have three nodes, right? VA is unknown, VB is unknown, and VC is also unknown. So we need to do KCL at all those nodes. Okay, let's do the first KCL, which is at VA. Let's do KCL at VA. And KCL said that the sum of the current that goes in will equal to the sum of the current that goes out. And the only current that goes in is this current here, and that will equal to 4.5. Okay, let's write that. So I have 4.5 ampere. And then that will equal to the current that goes out, this one here, but we need to calculate this using Ohm's law. So let's see here, the current comes from VA. So we'll have VA first here. And then the current goes to the reference node. So the voltage there will be 0. So I'll have minus 0 here. All of that will need to be divided by this resistance here, 1. Why? Because this is voltage and this is resistor. We get current from that. Okay, and then another current that goes out is this one here. And that current comes from VA. And then the current goes to VC. So I have VC here divided by 6. Good. We can multiply both sides here by 6. 4.5 multiplied by 6. I think that will be 9 multiplied by 3, right? And then that will be 27. Okay. And then 1 and 6 will cancel into 6, so I will have 6 VA from this term. And then 6 and 6 will cancel each other, so we'll have plus VA minus VC. So we will have 7 VA and then minus VC. Okay, and all of that will equal to 27. Good. Now let's save this as equation number 1. Good. Now let's do another KCL, but this time at VB. KCL at VB. Okay, and then the sum of the current that goes in will equal to the sum of the current that goes out, right? That is what KCL said. The only current that goes in is this one here, and that current will be VC, where the current came from, minus VB, where the current goes to, divided by the resistance between them, which is 2. Good. Now let's get the current that goes out. So the first current that goes out is this one here, and that current will be VB, where the current comes from, minus 0, where the current goes to, divided by the resistance between them, which is 12. Good. And then the current that goes out, we will have this current here, and that current will be VB minus 30. Right? VB is where the current came from, 30 is where the current goes to, divided by 4. Good. Now let's multiply both sides here by 12. And so we will have 6 VC minus 6 VB. Okay, and then 12 and 12 will cancel each other, so we will have VB. And then 4 and 12 will cancel into 3, so we will have plus 3 VB. And then minus 90. Good. Now we will have VB plus 3 VB, that will be 4. 4 plus 6, that will be 10. So we will have 10 VB. Now let's move this 6 VC to the right hand side. So we'll have minus 6 VC. And then let's move this minus 90 to the left hand side. So we'll have equal 90. Okay, and that is equation number 2. Okay, maybe let's save equation number 1 and number 2. And let's do another KCL at VC, because we still need one more equation. Okay, let's do exactly that. Okay, the last KCL that we need to do is at VC. Let's do that. KCL at VC. Does KCL said? It is said that the sum of the current that goes in will equal to the sum of the currents that goes out. The only current that goes in is this one, and that current will be VA minus VC divided by 6. And then that will equal to the current that goes out. I will have VC minus VB divided by 2. We can cross multiply here, so we'll have 2 VA minus 2 VC, and then we will have 6 VC minus 6 VB. Okay, what can we do next? I think we can move this 6 to the left hand side, so we will have 6 minus 2. Oh no, okay, we will have this, I think we will have 2 VA here plus 6 VB, okay, and then minus 8 VC, and all of that will equal to 0. Okay, this is equation number 3. So we have 3 equations and 3 variables here. 1, 2, 3. Okay, let's do the fourth step, which is to solve the equation. Okay, maybe let's clean up our slide a bit. Okay, let's do the fourth step, which is to solve the equation. And I think the fastest way to do it is by using calculator, right? Because if we are using algebra, it will take a very long time. And by calculator, we just pressing the buttons and we get the results. Okay, let's see that. Let's set this up, and equation solver is number 5. 3 variables is number 2. Okay, but we have to be careful because our variables is VA, VB, and VC, right? We have 3 variables. Okay, so we will have 7 here for the coefficient of VA, but we don't have coefficient for VB, so we enter 0 here. And then for VC, we enter -1. And the result vector will be 27. Good. And then the second one, we have to be very careful because we don't have the VA term here. So we enter 0 first. And then we will have 10 VB. And then we will have -6. And all of that will equal to 90. Okay. And then we will have 2 VA. 2 VA, and then 6, and then -8, and then 0. So we can get our X value, which is our VA. So our VA will be 6 volt. So we'll have VA is equal to 6 volt. And then what is our VB? VB will be our Y value, which is 18 volt. Okay, that is nice, 18 volt. And then we will have our PC value here, which is our Z value, which is 15 volt. 15 volt, but then the question does not ask about VA, VB, and VC, and we need to do one more step, which is to answer the question. Okay, what is the question? It is asking about V, but we have V is equal to VC, right? So we will have V is equal to VC, and we know that VC is 15 volt. So we have 15 volt, and let's plug in into our goal here. So our goal is V, so that will be 15 volt. And we have achieved our goal here. And I think that's all for this video. Thank you for watching. Let me know if I made any mistakes in my calculation. Thank you for watching. See you in the next video. Bye bye.